Alright, here's an example. We're going to factor p to the 6th power minus 1. Solution. Want to use the following formula. It's a cubed. Should we use the cube or the square? That's a tough one. Let's try the square. A squared minus b squared equals a plus b times a minus b. Let's see where that takes us. I was going to use the difference between cubes, but I decided to use the square. So that gives us p to the 6th minus 1 is p to the something squared minus 1 squared. So what's the something in p? Let's see, that'll have to be 3 because 2 times 3 is 6. Now let's go ahead and use the formula. That gives me p cubed, which is the a, plus 1, that's the b, times p cubed, that's the a, minus 1. Okay, now we will use these two formulas. A cubed minus b cubed equals short parenthesis, long parenthesis, a minus b times a squared plus ab plus b squared, and a cubed plus b cubed, which equals a plus b, then a squared, then comes the minus, a times b plus b squared. We're going to use both of those because we actually have the sum of two cubes and the difference between two cubes. So this is equal to, the first one is the sum of two cubes, p squared plus 1 squared. P cubed plus 1 cubed. So that factors as p plus 1, it's the second formula, times p squared minus 1 times p is p plus 1 squared is 1, times the factorization of the second, p cubed minus 1, that factors as p minus 1 times p squared plus 1 times p is p plus 1 squared. And we are finished. See, let me just say something about this problem. We had a choice at the beginning. We could have rewritten this problem as the sum of the difference between two squares or the difference between two cubes. So it turns out that it's easier if you do the sum of two squares, the difference between squares first. So when we have a choice between a squared minus b squared and a cubed minus b cubed, use a squared minus b squared formula first. That's the moral of this story. Use that first, and then you should be able to possibly even factor further afterwards.